Hello, fifth grade scientists. This is Mr. Miller coming to you live from my coronavirus bunker. And today is Hawaiian Day in the bunker, so I dressed appropriately. Hopefully, you dressed up too. Today, we want to continue talking about the Earth and what happens to the Earth. And I thought you should have watched the video already, and you're taking notes at this point, and you should still have some room between those four questions I gave you to add to your notes. So I want you to think about what I'm going to present to you, and I'm going to share my screen so that you can look and I can explain what I'm talking about. Now, if you remember, we said the Earth is round. The Earth, we know, is spinning. And we also know that the Earth is traveling through space and orbits the sun. Now, this is a picture of a globe. Last week in history, we talked about the globe, and we talked about this line here that is directly the side of the planet that's pointed towards the sun. So the sun would be over in this direction. And we said the equator is that imaginary line that splits the Earth into the northern hemisphere and the southern hemisphere. So if I spun this globe, if you look, it's on this axis. So that if I take it and spin it, I might find the compass rose and I can verify that north is up here, south is down here. In the video, it said we're not straight up and down. We are tilted at an axis of 23.5 degrees. So that's what this looks like. Okay. Now, also on this globe, we also have continents. We also have oceans. Now, we know that this is spinning. And do you know how fast it spins? Well, we are spinning like a top. And you saw a picture of a top in the last video. And because we're spinning at an angle, this top is wobbling, okay, as it travels. If I were to stand here at the equator, okay, and the Earth is spinning, it spins at an incredible speed. It spins at 1,000 miles per hour. Now, how fast is 1,000 miles per hour? Well, it's 5 or 6 times faster than your car will ever go. It's 5 or 6 times faster than an Indy race car. Okay, a jet airplane can travel upwards to 500 miles an hour. So it can't even go as fast as the Earth is spinning. Now, why does it feel like when I'm sitting here, I don't feel like I'm moving? You know, if I get on a merry-go-round or a carnival ride and it starts spinning, I can feel that spinning. Why can't I feel the earth spin? The answer is our bodies are designed to handle that spin, and we don't even notice it anymore. So that is pretty incredible. The other thing we know is the direction at which this spins. So if I look from the top here from the north, and remember up here at the north, we have the North Pole, the Arctic. And if I look, then this Earth is spinning counterclockwise. So that means it's spinning from this direction to this direction. So it's spinning from the west to the east. Now, how do I know that? How can I verify that? How can people verify that in the old days before they even knew about rockets and got to see pictures of the Earth? Well, if the sun is over here and we are rotating this way, by the time our country, and of course, this is Asia, Africa, our country's getting over it here. Here's Australia. But as it's going, sunrise is always in the east. So if I get up in the morning and I see the sunrise and I'm facing that sunrise, I'm facing east. And so now I can turn my body. I can put my hand out towards the east. I can put my other hand outstretched, and that is west. Okay. Now, if east is on this side, west is on this side, which way is my face pointing? Well, if we go back and look at the compass rose, my face is north. So if you're in the woods and you don't have a compass, you notice things of where did the sun set? You make a mark, oh, it's set behind that tree. So when you get up, you can say sunset west, put your arm out, put this, and now you got north, south, east, and west. And you can look, and let's say a mountain is north and I want to go north, then I want to walk towards that mountain and I won't get lost. All right. So that's the speed, 1,000 miles an hour. That is incredible. And the rotation of the Earth, because we're rotating at 1,000 miles per hour right here at the equator, it takes approximately 23 hours and 56 minutes and then a few seconds to make one revolution. Now, why is that important? Well, because our calendar is set up in years, months, weeks, and days, and a day is the exact time it takes for our Earth to rotate one time. So as it rotates, half the day we're pointed towards the sun, so now it's light, it's day. As we rotate to the other side away from the sun, now it becomes night. And that is important because in science, we know that we lose heating, we have temperature changes, which causes many, many things to happen on our planet. All right, so now I want to watch another video with you, and I'm going to increase the size. Oops, there we go. And we are going to be pausing, and you should be pausing this video anytime you want to take some notes. You can always replay the video and catch up and make sure that you get your notes correct. And when you pause, you should see me do, but of course I'm not paused, right? So if you see my lips moving, my eyes turning, you didn't pause the tape. And all I have to do is go down to this little bar and I can move and I can go through this video. All right, so this is a very short video. It's only about a minute.
Found in the science of the seasons. Like all seasons, summer is the result of an astronomical fact of life. The Earth is tilted on its axis, 23.5 degrees. As the planet moves in its yearly orbit, that angle causes the position of the northern hemisphere to change relative to the sun. In the winter, it's tilted away from the sun.
So let me move my picture. So now, just that short little piece of video, the Earth has traveled half a year. And because the tilt doesn't change, the rotation doesn't change, but the position of the Earth relative to the sun changes. Now, this is called winter, but it's winter in the northern hemisphere. Down in the southern hemisphere, it's summer. So that's why people during the harsh winter fly south, because they want to be close to the equator because it's always warmer. Because the equator, as we learned in geography last week, gets the most direct sunlight. So it heats up faster. So it tends to be much warmer. They don't have winters on the equator. They have rainforests. Okay. So here, most direct sunlight is hitting the southern hemisphere. Now, what do we know about the North Pole? Well, we know the North Pole is the northernmost point of our globe. This stick shows us our angle, but there's not a stick sitting through the Earth as we know it. But right up here, if you look during the winter, the Arctic gets no sunlight. And if you go up into the Arctic and you go up into parts of Alaska, you'll find out that during the winter, they don't see the sun for 3 months. They call that the dark time. Okay. And as this rotates or as it orbits, and we'll watch it orbit.
In the summer, it angles towards the sun.
So now A half a year later, 6 months, we went from the middle of winter to the middle of summer. And the only difference is now this northern hemisphere is directly pointing towards the sun. It warms up. The southern hemisphere, it cools off because it has less direct sunlight. And now the South Pole is dark. There's no sun. During the summer, if I look, because of the angle in the Arctic, in northern parts, close to the North Pole, it's light for 3 months. The sun never sets. The sun actually goes in a circle. As this turns, we watch the position of the sun going into a circle. If we get down by the equator, then we have sunrise, sunset. Okay? Now, the other thing we need to talk about, as this Earth orbits the sun, we said its orbit is not a circle. It's an ellipse. An ellipse is more egg-shaped. So as this moves during the summer, gets far away from the sun. As it moves, it actually gets closer to the sun in the spring and the fall. And the only difference is it tilted towards the sun? Is it tilted away from the sun? So in most places on Earth, we have 4 seasons. We have summer, we have fall, we have winter, and then it turns into spring, and then we go back into summer. And that happens every year because the Earth is rotating. Now, besides spinning at 1,000 miles per hour, how fast do you think the Earth orbits the sun? Well, it's moving at an incredible 67,000 miles per hour. 67,000. That's very fast. But because it has to travel so far, and it travels about 584 million miles to go from one side of the sun and back to the position, it takes 365.256 days. Now, why is that significant? Well, 365 days is a whole year. And we divide that up into 12 months. We divide each month into 4 weeks. And now we have a nice calendar. But we know we can look at the calendar and we know what's going to happen to our weather. During the winter, we know it's going to be cold. During the summer, we know it's going to be warm. Okay. And in the fall and spring, it can be very nice. It's much better than winter, that's for sure. So, um, because the orbit takes a little more than a year, that means a quarter of a day more. Every 4 years, we have what's called a leap year. And they sneak an extra day into the calendar just to keep the orbit in line. So consider that. And hopefully you've paused, you've gone back, maybe you've listened to this whole video, and you're going to replay it so that you can answer your questions. Make sure you're filling in, adding some detail to those 4 questions. All right. Awesome. Thank you, guys.